Hey guys, welcome back to the channel. Now as you can see, this is another new video of 9th standard, and as of this video we will be dealing with the chapter lines and angles. Well, if you are new around the channel, then we will usually upload some videos relating to the 9th standard and the 10th standard portions, which you will find it helpful for your exams and tests. So there will be some concepts and some questions which will be solved in this video, so make sure to check out all the videos pertaining to the 9th standard and 10th standard portions if you wish so. Now, if you like the content that we provide, then please make sure to give a like to the video and subscribe to the channel to support us, and don't forget to press the bell icon to stay updated in our future videos. So, as I've already said, without any further delay, let us jump into the video. So, let us start with this week's chapter, which is lines and angles. Well, what are we going to learn especially in this lines and angles chapter? Well, in this chapter we are going to deal with some certain properties of angles and certain types of angles and many other things. So watch until the end of the video to find out some new things and new concepts relating to the angles. So let us move on with the basic terminologies. Well, in the lines and angles chapter we are obviously going to deal with some lines and some angles. Well, as of the basic terminologies pertaining to lines and angles, well, let us first see what is a line. Well, if you have already heard of this word line, then a line is something like this. It is something like a straight line which extends in both the sides to infinity. So on this side also it goes until infinity, and this side also it goes until infinity. So this is something which is a representation of a line, and a line cannot be measured. So that is a line. Now what about the sub part of line which can be measured? So another part of a line or another basic terminology is a line segment. So line segment is something like this. Take 2 points over here, something like this, join these 2 points, and you cannot exactly call this a line because it is not infinitely extending on both the sides. So it is not extending, as it is not extending on both the sides, it cannot be called a line. So it is a line segment where this line segment, suppose I mark this point as A and this point as B, then AB is a line segment which can be actually measured. So when you take your scale and place it under this line AB, then if you can measure a distance of 6 cm or a length of 6 cm, then it is very well called a line segment. Why? Because you can only measure a line segment and you cannot actually measure a line. Well, a line is basically extending in both the sides towards infinity. So we now know what is a line segment, what is a line, and next basic terminology is a ray. So what is a ray? So a ray is just the combination of both line segment and line. So in basic terms, the ray is one side restricted and another side free. So this part A, I can mention it as A. So A is the vertex at which it is restricted, and the other side it extends till infinity. So that is why I said it is a combination of both the line and the line segment. At one side it is restricted and at the other side it goes till infinity. Now, can we measure a ray? Well, we cannot measure a ray since it is going to infinity and on the other side. Well, in the case of a line segment, we can very well measure it because there are two defined points, so that we can place our scale under that and we can get a particular measurement. But over here, we don't know where this line ends or where this ray ends. So we don't have the two specific positions of two endpoints, so we cannot take the measurement. Now we know the basic terminology, which is the line segment and the ray. Now why are we learning about the ray? Well, this ray is very important in formation of an angle, which is in the name of the chapter. So since we are going to read about angles, now we have to learn about how angles are formed in the first place. So an angle is formed when two rays, something like this. So two rays originate from the same restricting point, which is called the vertex. Let me say that again. So take this point A as the vertex. Now this is the vertex, as I already said, this is the point which is restricting these two lines at a particular point. Now this vertex A is a common vertex of these two rays. So this vertex A is the common vertex of these two rays which is starting from here. So two rays are starting from a point A. So this is how an angle is formed. Well, what is an angle exactly? Well, this region over here, this arc is called an angle. Now if you can take a protractor and keep the center of a protractor over here and one of the legs or one of the rays on the lines, your protractor will look something like this, and you will have a center point over here and you will have a base over here. So keep the center point A at this point exactly. So keep this point A over here and the ray something like this. So if your ray is something like this, then you keep one of the legs of a protractor like this, and the other ray is something like this. So if this is your ray and you are keeping your protractors over there, now how do you measure your angle? Well, in your protractor there will be some 10 degrees, 20 degrees and some marking something like that, and over here will be your 90 degrees, 80, 70, 60 and so on. So there will be equal intervals of marking all over your protractor. And how do you find out the angle exactly? Well, the specific method that you use to find out the angle is that you see at which point you place the one of the rays at the horizontal line and find out at which point the other ray is intersecting. So suppose over here it is intersecting at 70, then the angle between the two rays is 70 degrees. That is how we exactly measure the angle between two rays. Now over here let us consider that the angle between these two rays is 45 degrees. Now what is 45 degrees, or what does this 45 degrees exactly represent? Now an angle usually measures or represents the distance between these two rays. Now how does it exactly measure the distance over here? Well, if you draw an arc or which is a semicircle something like this, then this arc over here is exactly 45 degrees. Whatever arc you draw using a compass and the center as A and whatever radius, suppose keep a compass over here and draw certain arcs. One arc like this, another arc like this, another arc like this. All of these arcs represent 45 degrees each. So all of these arcs measure a certain distance between these two rays which is 45 degrees. Okay, now we know what the angle represents. Well, basically in layman's terms, the angle represents the distance or the basic measurement between two rays. Well, now we know what is an angle and how can we find out the angle between two rays. Okay, now let us further move on to find out different types of angles and properties of some angles. Well, angles are divided into 5 types. Well, the first type is that one type is acute angle. Well, what is an acute angle? Well, acute angles are the type of angles where the angle when measured comes out to be lesser than 90 degrees. Let me give you an example. Suppose this is my common point A. I draw a ray from here like this and I draw a ray from here over like this. Now I measure this line, measure this degree or the angle to be 30 degrees. Now this angle is clearly lesser than 90 degrees, right? Hence, this type of angles are called acute angles. Now you must have heard acute angles in your 8th standard itself. Now, what is the next type? Well, you guessed it. The next type is called the right angle. Well, what is a right angle? Well, right angles are the angles which when measured come out to be 90 degrees exactly. So let me give you an example over here. Now this is one ray, this is my vertex over here, this is my another ray. Now I measure my angle using a protractor and I can see that this angle is exactly 90 degrees. Now 90 degrees, as the angle is exactly 90 degrees, I can call this type of angle as a right angle. Now, as of my third type over here, it is called an obtuse angle. Now, what is an obtuse angle? Well, you guessed it right. An obtuse angle is neither an acute angle or a right angle. Well, what is left? Well, if an angle, if you measure, are larger than 90 degrees. So, you already saw a case where the angle is lesser than 90 degrees, an angle is equal to 90 degrees. Now, in this case, the angle is greater than 90 degrees. Well, let me give you an example. If you take one ray over here like this is my common vertex. Take another ray over here. Now I am not using a scale, so the lines are a bit wobbly. You can use a scale and get the measurement exactly. So now this is my common point A and I measure this angle to be 120 degrees using a protractor. Now you can clearly see that this angle 120 degrees is greater than 90 degrees. Hence this angle can be called an obtuse angle. Now these are the 3 basic types of angles, which are the acute angle, right angle and the obtuse angle, which you must have already learnt in your 8th standard or must have heard at least. Okay, so the 3 types are already done. Now what about the other 2 types? Since I have already said there are 5 types of angles. Now well, according to the other types, well, let us take the 4th type of angle, which is called the straight angle. Well, straight angle, what is this straight angle? It is rather new to me. Well, if you take one ray like this is my common point A, and if you take another ray something like this which is exactly horizontal to the previous ray, then what is the angle that you get? Well, if you take a protractor and try to measure out the angle, then the angle will turn out to be exactly 180 degrees. Well, why is it 180 degrees? Well, if you can measure it, then you can get 180 degrees, but why does it have to be 180? Well, you can see a similarity between this figure exactly and a line. Well, what is a line? A line is something like this which extends to infinity in both the directions. Now over here, when a ray is originating from a single point in both the directions horizontally, then you can see similar to a line, it extends to infinity in both the directions. Now any point in a line is 2 rays. Now the angle between them is 180 degrees. Okay. So my fourth type of angle is a straight angle where the angle is measured to be 180 degrees. Hence it is called a straight angle. Now what about the fifth type? Well, the fifth type is called the reflex angle. So what is it? Well, the fifth type is called a reflex angle. Well, what exactly is this reflex angle? I haven't heard of this type of angle. Well, let us take an example. Now what is this type of angle called? Well, if you take this measurement over here, suppose if you get it like 30 degrees or 45 degrees, which is lesser than 90 degrees, then this type is called an acute angle, which we have already learned. Well, what does it do with the reflect angle? What does it have to do with the reflex angle? Well, as I've already said, angles are used to measure the distance between a measurement between two such rays. Now, if this is a measurement, then this angle is also a measurement, right? This is the opposite direction of the previous angle which we measured. So now what does this represent? Well, this angle which is opposite to the original angle that we measured is called the reflex angle. Now, how can we measure a reflex angle using a protractor? Now, in general, you can find out the reflex angle by just doing 360 degrees minus the angle which you have already measured, which is 30 degrees in this case. So 360 minus 30 degrees will give you 330 degrees, and in this case the reflex angle is 330 degrees over here. Now what is, I again say, what is a reflex angle? Well, a reflex angle is the angle which is opposite to your measured angle, and it is exactly the other sided measurement of your original measurement, which is either acute angle, right angle, or your obtuse angle. Now let us take another example of a reflex angle. Now if I plot something like this, if I have two rays in such a manner, what do you call this type of arrangement? Well, if this angle seems to be an obtuse angle, since if I get a value of 120 degrees or something like that, then this seems to be my obtuse angle. Now what is the reflex angle of this obtuse angle? As I already said, this measurement is called the reflex angle, or the other sided measurement of your original measurement is called the reflex angle. Now how do you find out the reflex angle? Exactly, you do 360 minus 120 degrees. Now what do you get? 360 minus 120 is 240 degrees. Hence your reflex angle, measurement of your reflex angle is 240 degrees. Now the next case of reflex angle is something like this. Now you saw for acute angle as well as the obtuse angle the reflex angle types. Now take the example of a right angle. Your right angle is something like this. This is your common vertex. This is your 90 degree right angle. Now how do you find the reflex angle of this side? Well, you can do that easily without my assistance. Now how do you find out the reflex angle? This is your reflex angle actually. Now you do 360 minus your found out angle, which is 90 degree already. So 360 minus 90, which is 270 degrees. Hence my reflex angle is efficiently or effectively 270 degrees over here. Now I have effectively said all the types of angles, which are the acute angle, right angle, obtuse angle, straight angle, as well as the reflex angle. So these are all the types that we had to see in this part. Now moving on, we will be seeing some properties of these angles. So as for the first two properties that we are going to see right now, those are the complementary angle and the supplementary angle. Well, what are the complementary angles first? So what is a complementary angle? Well, complementary angles are the angles which when added gives 90 degrees. So let me give you an example over here. So suppose one of my angles, something like this over here, gives me a measurement of 30 degrees. So this angle, this type of angle over here, once again I will draw this again. So according to my complementary angle, suppose I take one such angle like this. So this angle, well, this gives me a measurement of 30 degrees. Now if I have another angle something like this, another angle over here, something like this, and this angle is 60 degrees. Well, it is not clearly differentiated between 30 degrees and 60 degrees over here since I am drawing it in freehand, but do try this out with a pencil and scale and a protractor as well. Now over here, these two angles, or if I take this as A and B, then these two specific angles, set of angles, which when added gives us an angle, total angle of 90 degrees. So this plus this will give us a total set of angles which is 90 degrees. Now these angles are called complementary angles. Now complementary angles are the angles which when added gives us a total of 90 degrees. So that was the basic definition of complementary angles. Now let me give you a basic example and yet another type of complementary angle. So what if you have something like this? What if you have one ray over here, something like this, one angle, one set of angle over here and another over here. So what if you have, this is the common vertex over here and you have three rays protruding from the same vertex. Now you find out this angle over here is 45 degrees. This angle over here is 45 degrees. Now you find out over here this angle is also 45 degrees. Now when you add these two angles over here, this angle A, this angle over here is 45 degrees. Let me measure it as B, C and D. So this angle BAC, I write it like this, angle BAC. Just remember the notation, I can mention angles like this. So angle BAC is equal to 45 degrees and angle CAD is also equal to 45 degrees. Now when I try and add these two, angle BAC, angle CAD, when I add these two, 45 plus 45 will give me an angle of 90 degrees, which is exactly angle BAD. So angle BAD is totally equal to 90 degrees. Now since these two angles are added up and gives us an angle, total angle of 90 degrees, this set of angles is called a complementary angle. Now this can be any measurement. Apart from 45 degrees, let us take 30 degree and 60 degree set. Suppose this is 30 degree and this is 60 degrees. If I'm just changing the numbers, but actually the representation may be different. So suppose this is 30 degrees and 60 degrees, I must be changing angle BSC as 30 degrees and angle CAD as 60 degrees. So this is 30 degrees, this is my 60 degrees. Now when I add them, they get us a 90 degree measure. So totally when I'm getting a 90 degrees, then the pair of angles are called complementary angles. Now that was the concept behind complementary angles. Now what about supplementary angles? Well, as of supplementary angles, let me give you an example over here. Now when two angles are added up, when a set of two angles are added up, something like this. So suppose if I take my obtuse angle over here, which is 120 degrees, something like this. So this is my original vertex A, this is 120 degrees, and when I take my other part, which is something like this. So this is my vertex B and this measures to be 160 degrees. Now when I add these two set of angles, then I efficiently get 120 plus 60, which is 180 degrees. Hence these two are called supplementary angles. Now you can derive the definition of this supplementary angles. Well, what are supplementary angles? Supplementary angles are the pair of angles which when added gives us a total of 180 degrees. Well, let me give you another example and a better depiction of what are supplementary angles. Now, if I have something like this, one such angle, something like this. So this is one of my angles over here. Now the point over here is A, and this is one of my other angle over here. So A, B, C, D. I measure it something like this. Now you can see my angle. If I measure my angle BAC, my BAC angle is 60 degrees. So my angle BAC, I'll write it over here. My angle BAC over here is 60 degrees. Now my angle CAD, if you can clearly see, if I can measure taking a protractor, this angle CAD over here can measure 120 degrees. Now if I add both of these angles, 60 degree plus 120 degrees, in total my angle BAD, this straight line over here, if I add this angle plus this angle, then totally I get a total angle of this, which is 180 degrees. So angle BAD, which is a straight angle, if you can remember the types of angles, angle BAD is equal to 180 degree. Hence angle BAC and angle CAD are supplementary angles to each other. Okay. So now you have learned two types of angles which are complementary and supplementary angles. And don't get confused if they are asking you to find out complementary and supplementary angles for different angles given to you. So if you take your exercise, then there might be some problems to requiring you to find out some complementary and supplementary angles. So don't forget these types of angles which exist, which are complementary and supplementary. Okay, so those are some basic types of, which are complementary and supplementary angles. Let us move on to some other types. Okay, so my other three types are the adjacent angles, linear pair and the vertically opposite angles. So these are all other properties of angles. Now we have already seen some two properties which were supplementary and complementary angles. Now what are adjacent angles? Well, adjacent angles are the type of angles which are closer to each other or nearer to each other. Now let me give you an example over here. So suppose if I take this angle over here and this angle over here, well, let me name those angles. So A, B, C, D. Now angle ABC, which is something like this. So angle ABC over here and angle CBD. This angle CBD over here, this angle, which when they both are called adjacent angles, because they are nearer to each other. So the ABC and CBD are closer to each other, hence they are called adjacent angles. So any angle that is closer to each other are called adjacent angles. So adjacent, it is very evident that adjacent means closer to each other. So linear pair, this is the fourth type or the fourth property. Well, what is a linear pair? So a linear pair is that when you take a straight line something like this, and you take a point over here which is A, and you draw a line something like this using that vertex A. Now you can clearly see that I have a straight line, I have divided that line into two such angles. So this 180 degree is divided into two angles differently. Now these two angles are called the linear pair. Well, let me give you an elaborate explanation. Suppose if I take, let me name these angles as B, C and D. Now if I take the measurement of this angle CAD, now angle CAD, if it turns out to be 30 degrees over here, then angle BAC must be 180 minus 30. Since BAD is a straight line, BAD is a straight line, and always the angle of a straight line is 180 degrees. Hence, using that concept, we can say that if this angle 30 degrees, this is 30 degrees, angle CAD is equal to 30 degrees, then angle BAC must be 180 minus angle CAD, which is 30 degrees. Hence this angle is 180 minus 30, which is 150. I can say that this angle is 150, hence when effectively adding 150 and 30, I get 180 and it totally adds up. So when I add 150 and 30, I get 180 degrees, and in total 180 degrees is the angle of a straight line, which is BAD. Now let me repeat what I said in simpler terms. Okay, so now when I take a different set of angles, suppose if I get an angle over here as 60 degrees, suppose this angle is 60 degrees, then what is the other angle? Well, according to linear pair, I can say that the other angle is 180 minus 60, which is 120 degrees. Now that was linear pair for you. Well, using linear pair, if you don't know one of the other angles, if you know one angle and if you don't know the other angle of a straight line, then you can see that 180 minus the found out angle is the angle to be found out. Well, 180 minus 60 is 120. Now we found out the unknown angle as well. But before applying linear pair or before using this property, you have to make sure that there is a straight line over here. So in this case, BAD is a straight line, and this angle this vertex A is responsible for another ray over here, which is AC. So another ray over there is there, so that on a straight line, so that you can see that this angle, which is BAD, this line which is BAD, this is 180 degrees. Now this is divided into two different parts. So one part is 60 degrees, then the other part is 180 minus 60, which is 120 degrees. Okay, now you know what is a linear pair, and you will better find out and better recognize a linear pair when you solve more problems. Now let us see what is a vertically opposite angles. Well, for this we have to take two intersecting lines. Suppose this is one of my line over here, and this is other line over here. Then vertically opposite lines. Well, what does it mean? What vertically opposite angles are the angles which are opposite to each other. So let me give O. This intersection point is O, A, B, C and D. So what are the vertically opposite angles over here? This angle BOC, angle BOC is vertically opposite angle to angle AOD. Now this angle BOC and AOD, what is the property of vertically opposite angles? Well, vertically opposite angles are always equal. So angle BOC is equal to angle AOD. Now what are the remaining vertical opposite angles? Angle AOB, which is this over here, is equal to angle COD. So angle COD is equal to angle AOB since they are vertically opposite angles. So you can use this property to find out vertically opposite angles. If one of the angles is given as 30 degrees, then what is the other angle BOC? Well, according to vertically opposite angles, if this angle is 30 degrees, then angle which is vertically opposite to this angle is also 30 degrees. Now, if this angle is given as 120 degrees, what is the other angle? This angle is also 120 degrees according to vertically opposite angles. Now, what about this angle? If this angle is given as 30 degrees and they are asking us for let me say this again. So, if this angle is given as 30 degrees and they are asking us for this angle over here AOB, then how do you find that out? Well, since this line is BOD is a straight line and OA is another line which is a ray. Now this angle is 30 degrees. Now according to linear pair, I can use 180 minus 30, which is 50 degrees, and 150 degrees. Now effectively I can use linear pair also and vertically opposite angles to find out some unknown angles. So those were the other three types or the other three properties which we can very well use in problems in case if we want to solve certain problems. Now what did we see in this video? Well, as of this video, we saw some basic concepts and basic terminologies relating to angle and its properties. Well, we saw some concepts and we saw some properties which were very important and which proved to be useful in solving such problems. Now, if you find this video helpful, then please make sure to give a like to the video and subscribe to the channel if you want more such videos in the future, and please don't forget to press the bell icon to stay updated whenever I post a new video. Now this video is done and I'll be meeting you in a future video. See you guys.